the 20th century came to a close, the Voyager 1 probe became the farthest object from Earth, forged by human hands.
We're really going into the unknown.
But nearly 15 years later, it achieved yet another milestone. Our emissary was the first to touch interstellar space. The moment was the crescendo to a saga, featuring the solar system's 4 outermost planets.
3, 2, 1. We have ignition.
In 1977, the twin Voyager probes departed to explore the giants.
How do gas giant planets like Jupiter, Saturn, Uranus, Neptune actually form in the first place?
Some of the things that were found were so surprising, they'd never been thought of when the spacecraft was being planned.
The Voyagers paved the way for a new era of robotic investigation.
It was tantalizing, but left so many questions unanswered that we just had to go back.
Some distant moons may hold the greatest potential for life beyond Earth.
If I had to bet on a best candidate for life in our solar system, I would pick Enceladus.
Now we are scouring our system's outermost regions, hoping to discover a new mystery planet.
We're looking for a needle in a haystack, but the needle looks like hay. That's why Planet 9 hasn't been found yet, if it is there.
During the early formation of our solar system, 4 small rocky worlds assembled where the radiation of an infant sun was strong enough to push away light gases and destroy all ice. But with great enough distance, hydrogen, helium, and ices like water and methane were plentiful. In this region, 4 giants were born: Jupiter, Saturn, Uranus, and Neptune.
Through their gravity in the early history of our solar system, these gas giants have vacuumed up all of the available gas.
Humanity's curiosity extended to these distant worlds.
We'd explored the inner worlds of the solar system. We'd gone to Mercury, we'd been to Venus, we'd been to Mars. But the big worlds of Jupiter, Saturn, Uranus, Neptune, they really beckoned to the scientific community.
An expedition to the giants would require crossing a protoplanetary graveyard, a ring of asteroids, leftovers from the solar system's formation 160 million kilometers beyond Earth's orbit.
We had to traverse the boundary in between Mars and Jupiter, the asteroid belt. And we only had some basic telescopic observations of some of these objects out there. And was it going to be a region of space that we could travel through?
In 1972, NASA's Pioneer 10 became the first spacecraft to enter the asteroid belt.
The asteroid belt in our popular imaginings is a rubble-strewn region of space, mountainous-sized objects crashing together in slow motion. It's nothing like that.
Scientists estimated a 1 in 10 chance that the spacecraft would suffer a serious collision.
There's a lot of rock out there, but it is spread over an enormous ring or volume of space. Collisions do occur, but they are not as frequent as you might imagine.
7 months after entering, Pioneer emerged, triumphant.
Having a spacecraft like the Pioneers extend their reach out into the solar system was, again, another important stepping stone in our exploration of the universe.
By year's end, the probe completed a flyby of Jupiter, using the planet's gravity to escape the solar system. Pioneer 10 remained our most distant spacecraft until 1998.
A great deal that is most interesting in our solar system was beyond our reach until Pioneer 10 showed us the way.
In the 1960s, engineers at NASA's Jet Propulsion Laboratory noted an imminent alignment of the outer planets. A spacecraft would be able to harness the gravity of each and swing from one to the next using minimal amounts of fuel.
It was recognized that you could do a grand tour, the idea of rendezvousing with more than one planet.
But if NASA missed their chance, the alignment wouldn't reoccur for almost 2 centuries.
Voyager was an epoch-making moment in the annals of spaceflight.
Twin probes were crafted, Voyager 1 and Voyager 2. Together, they would provide unprecedented access to the outer reaches of our solar system.
It was going to be the first time that we had pictures of such incredible detail of those distant bodies.
Let's measure these things in great detail, but moreover, they're going to keep going. And let's build them for the long term. Let's see how long they can last.
1970s technology would have to endure the harsh environment of space for decades.
The Voyager spacecraft, by today's standards, are quite basic vehicles. They had old television cameras on board, not too different from what might have been used in a television studio. Their recording systems were 8-track tape.
Nevertheless, the equipment was capable of capturing essential details of the mission targets.
The modern ships that sail to the planets are unmanned. They are beautifully constructed, semi-intelligent robots.
Each Voyager probe also carried greetings from humanity.
The legendary scientist, astronomer and communicator Carl Sagan decided to send a cultural object along with the scientific missions on the 2 voyages, and this was the famous Golden Records.
I send greetings on behalf of the people of our planet into the universe, seeking only peace and friendship, to teach if we are called upon, to be taught if we are fortunate. And it is with humility and hope that we take this step.
Nominally, it's a message for any alien species who happen to find them, but actually it's a message to us as humans that we have something a little bit special on our planet that we would like to send out into space.
If extraterrestrial life could decipher the instructions to play it, the record would reveal 115 images, 90 minutes of music, and greetings in 55 different languages.
3, 2, 1. We have ignition, and we have liftoff of the Titan Centaur, carrying the first of 2 Voyager spacecraft to extend man's senses farther into the solar system than ever before.
Voyager 2 was launched first on August 20th, 1977.
This is the most exciting mission that I've ever worked with. We're really going into the unknown. It's going to be one of the most scientifically productive of the planetary missions.
Voyager 1 followed 2 weeks later. In less than 2 years, each arrived at the first proverbial stop on their grand voyage. The largest of all the gas giants, Jupiter contains 2.5 times the mass of our solar system's other planets combined.
Jupiter formed from all these little globules of matter basically colliding together in the very early days of the solar system formation.
The infant world hungrily swallowed nearby asteroids and comets, bulking its mass even further.
Eventually, when it cooled down, it was able to accumulate gases. So now it has the sort of a solid core and then this huge amount of gas around it.
Jupiter is truly the king of the planets.
It's the dominant force in our solar system except for the Sun.
Pioneer 10 had captured our first close-up images of Jupiter, but the Voyagers would expose even more of the planet's secrets.
We knew there was something going on, and when Voyager got close, it saw a very complex place. It saw weather patterns more similar to here on Earth.
One of the key targets, Jupiter's Great Red Spot.
It's like a tropical cyclone, but huge. It was first observed almost 400 years ago. Just to simply exist so long, it's fascinating, and it's still not completely well understood.
In the 19th century, the Great Red Spot stretched 3 Earths across. But when the Voyagers visited, it had decreased to 2.
The scale of Jupiter in particular, I think, is one of the more striking reminders of just how small we are when you look at features and realize the entire Earth can fit within, with space to spare. It really is the land of the giants.
While Jupiter's massive cyclone had been known for centuries, Voyager 1 revealed a completely new feature. Rings, like Saturn. So faint that no one had spotted them earlier, the rings were likely formed by Jupiter's moons shedding dust, which settled into their parent's orbit. Future discoveries would reveal rings around every gas giant in our solar system.
Saturn turned from being the solitary jewel to actually being just one of a whole family of ring planets in our solar system.
The Voyagers also investigated some of Jupiter's natural satellites.
The moons of Jupiter, pivotal in human history because of Galileo's discovery of the 4 large moons of Jupiter, that it kind of turned our view of the solar system on its head.
Galileo's 1610 revelation helped disprove the geocentric model of the universe. Earth, the other planets, and their satellites all moved in orbit around the Sun. The innermost Galilean moon, Io, is a hellish world, home to as many as 400 volcanoes.
The volcanoes are spewing sulfur dioxide, and they're actually producing a ton of sulfur dioxide per second.
The Voyagers captured a surface covered in lava and sulfur, in part caused by the moon's close elliptical orbit around such a massive body.
Normally a moon wouldn't have such an active core, but it's actually being caused to have an active core by Jupiter itself.
The uneven gravitational tug of Jupiter drives rocky tides. Io's surface bulges in and out by as much as 100 meters each cycle, and the frictional forces keep its interior warm and subsurface rock liquid.
It is the most volcanically active body in the solar system because of the internal pressures and temperature that generates.
But it's the smallest of the Galilean moons, Europa, which holds the most interest. Scientists believe Europa has a subsurface ocean with more water than exists on Earth.
Europa has liquid oceans under its heavy ice shell.
We can see the effects of currents in that ocean, convective currents flowing to the surface and breaking up the ice. It's a circulating ocean.
And where there is water, there is the opportunity for life.
We're talking now about the potential of Europa being a living world.
We've got liquid water, we've got a strong energy source, and organic chemistry. On Earth, those same ingredients in less than 1 billion years gave rise to life.
closer images of Jupiter and its moons would have to wait until the end of the 20th century. The Galileo spacecraft deployed from Shuttle Atlantis in 1989.
It's been a long time coming, but you have a go for deploy.
Galileo is on its way to another world. Fly safe.
But its journey to Jupiter would span 6 years. En route, Galileo witnessed an extraterrestrial collision. In 1994, the spacecraft watched as the comet Shoemaker-Levy 9 was torn apart by Jupiter's immense gravity.
Sometimes there's a lot of luck in space exploration. Celestial mechanics came together to give us one of the most spectacular events in our solar system.
Many thought that Jupiter's clouds would simply swallow the pieces up. However, as each fragment crashed into the atmosphere, they released more energy than Earth's entire nuclear arsenal.
Galileo was able to capture the distinct holes and the distinct impact craters, and that the biggest one was thousands and thousands of kilometers wide.
The collision of Shoemaker-Levy 9 demonstrated how Jupiter's gravitational presence affects our own world.
With Jupiter, we have this gravitational bully that has influenced our own history as much as that of all the other planets.
Jupiter, because of its gravity, pulls these things into it.
It is very likely that it has shielded us from asteroid and comet impacts,
which may help understand why life formed here.
Under the Galileo mission, 2 explorers ventured to Jupiter. A small probe accompanied the main spacecraft, bound for a brief but crucial encounter with the planet's atmosphere. Each arrived in December 1995. But while Galileo entered orbit, its probe dropped beneath Jupiter's cloud tops.
The Galileo probe was actually able to plunge down through that atmosphere and see if there was water.
The probe quickly hurtled to a final measured depth of 180 kilometers.
Did it rain from the clouds of Jupiter? What were the temperatures? What were the pressures like? Was there lightning in that atmosphere? And along the way, it discovered all of those things, proving the theories that we'd had about this dynamic world for the very first time.
After loss of signal, the probe was vaporized. In 2003, following its 35th orbit, a dying Galileo was steered into Jupiter's atmosphere, meeting the same fate. The craft had not been sterilized prior to launch. This act of destruction would ensure no life, had it survived the journey, could contaminate Jupiter's moons. For the next 13 years, we could only study Jupiter from afar.
Ignition and liftoff of the Atlas V with Juno on a trek to Jupiter, a planetary piece of the puzzle on the beginning of our solar system.
In 2016, the solar-powered Juno spacecraft arrived and settled into a polar orbit.
The purpose of the Juno spacecraft was not to show us the clouds of Jupiter once more, to actually understand more about what's going on inside the planet. How do gas giant planets like Jupiter actually form in the first place? We don't know how big worlds like that actually get built.
On each of its highly elliptical orbits, Juno passed Jupiter with only 8,000 kilometers to spare.
This is akin to skimming around a basketball just 1 centimeter from the surface, but we're doing this at tens of thousands of kilometers per hour.
Juno allowed us to understand what hides beneath the clouds, down to the core itself.
We've got a wibbly-wobbly core in the interior of Jupiter, generating this enormous magnetic field.
a magnetic field that is some 20,000 times greater than the Earth. Juno was actually built with a significant shielding just to prevent its electronics being fried by these close approaches.
Inside Jupiter, it ceases to be a gas giant. The hydrogen becomes compressed into liquid, and it takes on metallic properties.
Juno has helped us understand that structure in incredible detail.
As we enter the 1980s, both Voyagers approached their next target. The second largest planet in our system, named after the Roman god of agriculture, the ringed world Saturn. Saturn has been observed in the night sky since antiquity, and its rings revealed not long after the first telescopes were crafted.
When Galileo turned his telescope towards Saturn, he was really confused. No one in humanity knew that a planet could have rings around it. The best he could come up with trying to describe Saturn was that it looked like it had ears.
In 1659, Dutch astronomer Christiaan Huygens employed a more powerful telescope of his own design and deduced that Galileo's ears were actually a system of rings. Each Voyager spacecraft arrived at Saturn months apart.
The Voyagers revealed a huge amount about Saturn. They discovered rings that had not been detected from the Earth.
Rings 200,000 kilometres across, but only maybe 10 metres thick on average overall.
They were able to resolve the rings into their component parts, little chunks of rock and ice.
Dust grains up to boulders as large as mountains, racing around the planet at 80,000 kilometres per hour, with its own strange magnetic field suspending dust particles above and below the rings.
In the last day, we have learned a great deal about Saturn and its surrounding rings and moons from the dramatic pictures that have been brought back by the Voyager 2 spacecraft.
With Voyager's new data on the rings, their puzzling origins became a little clearer.
The rings of Saturn have been a mystery for many years in terms of how they came to be there.
Had they formed with the planet itself, or did they materialize later, Saturn's immense gravity destroying a smaller, wayward body?
Perhaps it was a relatively recent event in which an ice moon got too close to the planet to stay intact and became broken up into rings.
Christiaan Huygens also discovered Saturn's largest moon, Titan, in 1655. Later that century, an Italian-French astronomer by the name of Jean-Dominique Cassini discovered 4 more. In 1997, NASA, ESA, and the Italian Space Agency launched their joint exploratory mission named after both men. Cassini-Huygens.
In many ways, the Cassini-Huygens mission grew out of the Voyager missions because what we saw in the vicinity of Saturn was utterly tantalizing.
The mission consisted of 2 separate spacecraft.
The Cassini probe, which is a NASA project, and the Huygens probe, which actually came from Europe. These 2 teams from different sides of the Atlantic could achieve so much more, I think, than either project would have done alone.
For me, a highlight in the exploration of the outer solar system has to be the Cassini-Huygens probes. We've learned so much about not only Saturn, the beautiful ringed planet, its atmosphere, its rings, but also its many, many moons, which are really fascinating.
An extraordinary mission. 13 years of absolutely marvelous discovery. Some of the things that were found were so surprising, they'd never been thought of when the spacecraft was being planned.
Cassini-Huygens arrived at Saturn after a 7-year journey. The first mission to orbit the planet, Cassini provided unprecedented detail of Saturn's rings by flying through them. Mission Control had to precisely navigate the craft through the debris. Tensions were high on every pass.
What will it encounter as it passes through that ring? What effects will there be on the electronics of the system? Are there particles or small objects with which the spacecraft will collide and be destroyed? That requires some very, very clever use of orbital mechanics.
We saw evidence for essentially water falling out of the rings, something like 40 tons per second. The rings themselves are actually raining onto the planet's surface.
Cassini was able to observe the first hurricane-like structure on Saturn, the Great White Spot, and watch a hexagonal atmospheric structure at Saturn's North Pole change from blue to gold.
The hexagonal feature that's at the North Pole of Saturn is due to a massive hurricane, and it's about 50 times more massive than any hurricanes we get on Earth.
Again, there are weather systems like on Earth that they're on these gas giants, something we never would have thought of.
On July 19th, 2013, the Cassini spacecraft imaged Saturn and its entire ring system during an eclipse of the sun.
One of the most spectacular images it returned was actually from the far side of the planet, looking back towards Saturn with the sun lighting it up from behind.
Spanning over 650,000 kilometers, the picture detailed Saturn's second outermost ring, composed of fine icy particles. The photograph also features a pinprick of light, the Earth, 1.4 billion kilometers away.
NASA knew that the Earth was going to be in that shot and decided to say to everybody, on that day, at that moment, go outside and look towards the skies, because your photons will be emanating from the surface of the Earth and received by the Cassini spacecraft.
During its mission, Cassini snapped images of many Saturnian moons, but one held the spacecraft's focus. Enceladus is Saturn's 6th largest moon. Its distinctive southern stripes sit atop a saltwater ocean, buried kilometers below its icy surface.
Close inspection by the Cassini spacecraft showed cracks in that ice and showed water geysers spraying out from a subsurface ocean.
These eruptions fling material into space, and it means that you don't have to land on this moon to access this ocean. You just wait for a geyser to erupt.
And Cassini was flown through those geysers and was able to taste those waters and found that the water was warmer than we expected it to be. And it was full of both simple and complex organic chemistry. It suggested that there could be thermal vents at the bottom of an ocean where life could thrive.
If I had to bet on a best candidate for life in our solar system, I think I would pick Enceladus. If we can actually go to Enceladus in the future and send drones under the water and see what's down there, I think that will be an absolute watershed for our understanding of whether life could potentially exist in our solar system.
Maybe life really is common out there, or the conditions for life are common out there. And if this little cold place around Saturn has it, it's probably common.
Decades before Cassini, Voyager 1's brief encounter with Saturn's largest moon, Titan, whetted our appetite.
Without a question, the images that were returned this morning revealed a world unlike any of the others that we've seen.
It was tantalizing. It told us things that we hadn't known before, but left so many questions unanswered that we just had to go back.
The secrets of Titan were buried beneath its thick, hazy atmosphere.
It's opaque for the same reasons that we get this haze of smog in some of the more populated areas of the world. Titan's atmosphere is rich in hydrocarbons, mostly ethane and methane. And the effect of the sun's radiation on those hydrocarbons is to turn it into a very hazy atmosphere.
After deploying from Cassini on December 25, 2004, Huygens began a 22-day journey toward its target. Upon arrival, Huygens descended for 2.5 hours.
The European Space Agency sent a landing mission to Titan as part of the Cassini mission. It successfully soft landed on the surface and sent back a whole bunch of data.
The first craft to land on an outer solar system body, Huygens continued to transmit data for 72 minutes until its batteries were drained.
And it revealed to us a world that has ice mountains and sand dunes and river-like features, not from liquid water flowing from the surface, but from organic molecules of ethane and methane raining from its clouds, flowing across a water ice surface and flowing into vast lakes.
It was almost primordial. It was kind of like a snapshot of what we thought Earth was like 3 billion years ago when life was just starting to come into play. And if life formed on Earth in very similar conditions, maybe it's forming or has formed on Titan.
This is not life as we know it, but it's conceivable that something could be there. The chemistry is complex enough that life may form. Could we recognize it if it did, is perhaps another question.
After 20 years in space and 294 orbits of Saturn, Cassini was running out of fuel. The mission embarked on yet another risky first, a journey between Saturn's atmosphere and its rings.
The choice was to send Cassini through Saturn's rings, through a very small gap actually, and to do this multiple times to learn more about what was there.
Diving through Saturn's rings 22 times, Cassini sought to determine their age. In 2019, astronomers revealed the answer, somewhere between 10 million and 100 million years old, a fraction of the age of the 4.5 billion-year-old planet they encircle.
And then eventually the final swan song was to send it into Saturn itself for a very scientific ending where it was transmitting important data right until the last second.
The signal from the spacecraft is gone, and within the next 45 seconds, so will be the spacecraft. I'm going to call this the end of mission. Project manager off the net.
Four decades before Cassini's demise, Voyager 1's mission to Titan ensured a lonely outward path, a journey that sent it straight out of the solar system. Voyager 2 carried the responsibility of visiting the remaining planets, the ice giants Uranus and Neptune. Sir William Herschel first observed Uranus on March 13th, 1781, though he did not initially identify it as a new planet. After all, it was the first that had not been known to the ancients. Just over 2 centuries later, Voyager 2 approached within 82,000 kilometers of Uranus's cloud tops.
Uranus is an oddity that Voyager's eyes were able to show us really a lot of interesting features of very high jet streams racing through its polar regions and equatorial zones, and to show a little bit more detail than we can get from here on Earth.
Voyager 2 studied Uranus's unique atmosphere, manipulated by the planet's strange orientation. Uranus lies on its side, with a tilt approaching 98 degrees. It's thought that an Earth-sized object may have collided with Uranus long ago, pushing the planet over. Its atmosphere reaches the lowest temperatures of any planet in our solar system, plunging as low as -224 degrees Celsius.
The ice giants are so far away from the sun that they're receiving a really tiny amount of the sun's light, between 100th to 1,000th of the sun's light.
Uranus's distinct coloring comes from the presence of methane in its atmosphere, which exists in greater concentrations than in its larger siblings. But like all the giants, Uranus has its own system of rings. The brightest of the Uranian rings had been discovered a decade prior aboard the Kuiper Airborne Observatory, an airliner fitted with an infrared telescope. Voyager's observations brought the total to 11. Voyager 2 also provided up-close images of the moon Miranda, one of the strangest bodies yet observed in the solar system.
When that first of the series of Miranda images came in, just where it was supposed to, it was that sense of, oh my God, we did it.
It looks like a world that has been smashed up, torn apart, and then put together again really, really poorly.
One half of it is deep curved furrows on its side, and the other half of it is an average-looking pockmarked moon that you would see in orbit around another planet. And there they are, together. They're completely different, but they're in the one body.
Cliffs that are over 20 kilometres high, and the gravity of Miranda is so low that you could stand at the top of that 20-kilometre high cliff, look straight down, jump off the edge of that cliff, take 20 minutes to reach the bottom. You'd be able to land on your feet and walk away.
In August 1989, Voyager 2 approached the final target of its grand voyage, Neptune, which was first revealed not with a telescope, but with mathematics.
The planet Neptune was discovered by its gravitational pull on the planet Uranus. So before we even saw it from the light that it emits, we inferred that it would probably exist because the orbit of the other planets were kind of being pulled out of line.
To speak with Voyager 2 at so great a distance would require a new technical achievement.
Probes like the Voyagers, they're very quiet. The further you go, the bigger and bigger we need to make our receiver dishes to pick that up.
In 1986, NASA established its Deep Space Network, 3 communication complexes around the world that improved our ability to capture the weak radio signals from Neptune.
Our job is to send commands to spacecraft so they know where to go, what to do, and what information to collect.
Each complex of the Deep Space Network has a 120-degree field of view. To achieve full coverage, NASA built the first station in California's Mojave Desert, the second station in Madrid, and a third near Canberra in Australia. Once a mission travels more than 30,000 kilometers from Earth, it is always in view of at least one of the stations.
I describe it as being air traffic control for the solar system, or the postal service for the universe.
In 1987, the 3 main telescopes were expanded to better hear Voyager 2's Neptune encounter. When it arrived 2 years later, Voyager revealed at least 4 rings of ice and rock. It also discovered the Great Dark Spot on the planet's southern hemisphere, a raging transient hurricane the size of the Earth. The winds on Neptune can reach speeds of over 2,000 kilometers an hour, the fastest in the solar system. En route, engineers altered Voyager 2's trajectory so it could study the largest of Neptune's moons, Triton.
A world with a thin atmosphere, with geysers spraying out dark sooty material, not water ice as we'd experienced in some of the inner moons of the other giant planets, but dark material that thin atmosphere and winds were carrying across the surface, creating dark streaks on the surface of the moon.
Days later, it snapped a final photo. Neither Uranus or Neptune have been visited since.
The ice giants Uranus and Neptune were all but points of light to astronomers until the flyby mission of Voyager 2.
We started to realize Uranus and Neptune are very different than Jupiter and very different than Saturn. We kind of had this view pre these missions that the four gas giants were all the same.
We saw worlds that had some of the coldest temperatures ever recorded, with some of the fastest winds ever moving, where the energy for such dynamic systems is still a bit uncertain.
We've been sending deep space probes out for decades now, but there's these two planets that we know only from the visit of Voyager 2.
We really know very little about these planets, and it's very much overdue, I think, that we send back another probe and have another look.
We might have a reason to go back, but we have so many places to explore beyond Earth in our solar system. Where do we go? There's just too much to do.
Beyond our outermost planet lies a mysterious realm of small rocky worlds that the Voyagers would merely pass through. But they were not forgotten. 4.5 billion kilometers beyond our Earth lies a realm of icy bodies, the remnants of our solar system's formation.
The Kuiper Belt is a huge region at the edge of our solar system where the comets live. So it's a very, very mysterious region.
Despite its massive size, the Kuiper Belt wasn't discovered until 1992. Within it lies a world once called a planet, Pluto. Discovered by 24-year-old Clyde Tombaugh in 1930, Pluto was reclassified as a dwarf planet in 2006, following the discovery of several other objects in the Kuiper Belt that were similar in size. However, that has not detracted from our desire to unlock its secrets. The New Horizons probe was developed to expand Voyager's grand tour of our solar system.
The New Horizons spacecraft was able to go where the Voyagers couldn't go. They couldn't encounter that final traditional world of our solar system, Pluto.
The probe embarked from Cape Canaveral on January 19th, 2006.
There were so many unknowns about Pluto, how it was formed, what it would look like.
At a distance of nearly 5 billion kilometers, it would take over 4 hours to send and receive radio signals from the probe. The download speed from New Horizons was only 1 kilobit per second, 50 times slower than the dial-up modems of the 1990s. It took 15 months for all of the information it gathered to return to Earth.
Everybody was waking up in the morning, ready to download all the latest images that had come in and been processed and were all being put up online.
It's just amazing what this meant to all the people that worked on it, but it also meant a lot to people around the world.
Until New Horizons, scientists weren't even sure of the dwarf planet's actual size. They were able to conclude that Pluto is 2,376 kilometers in diameter, the largest of the catalogued dwarf planets. But it was the features on its surface that were truly astounding.
A world with nitrogen ice glaciers flowing across its surface into valleys underneath mountains that were 3 kilometers high, made from water ice, covered in a nitrogen snow.
The textures And the patterns make it look a bit like an artwork in places.
And surprised us by revealing an extraordinary heart-shaped region of very smooth landscape. It's a new surface, and by new I mean within perhaps 1 million years. Certainly not the ancient cratered surface that everybody expected to see.
As New Horizons departed Pluto, it revealed a naturally blue sky, created by nitrogen gas, just like on Earth.
The sun shining behind Pluto, lighting up that blue atmosphere and the blackness of deep space that we're traveling out into, leaving behind the worlds of our solar system to head into the interstellar void.
Observations of the outer solar system continue to raise as many questions as answers. Indeed, a number of objects beyond Pluto follow unusual orbits. Orbits that could hint at an unseen gravitational force. Another planet, currently dubbed Planet 9.
If we look at the other objects in the very outer solar system, some of the asteroids, the rocks that are floating out there, they seem to be pulled a little bit off target.
These orbits all seem to line up pretty well in one direction, and that tends not to happen by chance.
There could possibly be a very massive planet out there that we haven't yet discovered, Planet 9.
For it to be there, and for it to be having the effect that it is, it has to be pretty big.
Somewhere between Earth and Neptune, what we call a super-Earth, which is interesting because super-Earths are very common around planets around other stars. So one of the most common types of planets in all the other star systems just happens to be the one we're missing.
Mathematical modeling and computer simulations hint at Planet 9's existence, but it has yet to be observed directly.
Now, Neptune-sized objects would be quite big, and you might expect that we would see that pretty easily. Except that this could be 20 times as far away as Neptune is.
The light that we see from the planets is reflected from the sun. And if there is a ninth planet, it would be so far away from the sun that the light would be incredibly faint.
The problem is that the most likely direction that we think this thing might be in, this hypothetical Planet 9, is actually slap bang in the middle of the Milky Way, the most dense part of the sky as far as how many stars there are.
How do you separate what could be a planet, a dim reflecting object in the night sky, from the many other background stars? Well, it moves relative to these background stars, which to our telescopes essentially appear fixed.
As it would take Planet 9 between 10,000 and 20,000 years to orbit the Sun, it could remain a distant mystery for years to come.
We're looking for a needle in a haystack, but the needle looks like hay. That's why Planet 9 hasn't been found yet, if it is there.
The Voyagers are now the furthest objects forged by humanity. And as such, they've given us the most distant photograph of our home.
On February 14th, 1990, it took a final image, turning its cameras back to the inner solar system and taking a panorama, a family portrait, if you will, of the entire solar system. And within one of the beams of sunlight, a tiny pale blue dot. The Earth, seen from the perspective of deep space.
I think it made everyone stop and wonder a little bit just about how large the universe is and our place in it.
In some ways, Voyagers 1 and 2 have both already entered interstellar space.
There are a few ways to define the edge of the solar system. One is to say, where does the influence of the sun end? And that would be called the heliosphere.
Both Voyagers have passed that last remnant of our own solar system and continue into our larger galaxy.
They have fuel that will probably mean that they can send signals back until maybe the mid-2030s. It's quite amazing that something launched back in the 70s could still be talking to us so far into the future.
The Voyager probes carry with them a history of humanity as spacefaring explorers and the promise of future discoveries.
It's the serendipitous discoveries as you go further and further into unknown territory, which we look back on and say, didn't expect to see that.
The depths of space called, and humanity answered.
The Voyager spacecraft fundamentally changed our idea of what the outer solar system was like and showed us new worlds that beckoned to be explored.
And we have liftoff.
Our missions to the outer solar system have provided nearly half a century of milestones.
You really felt part of it. Every decade of your life, you saw something new about our own solar system. It was completely inspirational.
Each robotic surveyor has opened up the possibilities of future missions.
If we can actually go to Enceladus in the future, I think that will be an absolute watershed for our understanding of whether life could potentially exist in our solar system.
These distant travelers are a monument to human exploration.
It makes all of the solar system and beyond a human place, because that's how far we've gone.